Hi students, so I'm going to quickly go over this enzyme quick check. Obviously there are two different versions, but you should be able to navigate whatever version you have because the order is just slightly different. It's the same thing. So this enzyme quick check measured, do you know what an enzyme does? Can you follow a diagram? Can you analyze a graph based on enzyme activity? So enzymes in your body are amazing protein machinery that do jobs in your body. They allow reactions to happen. So they're either building something up like DNA or building your bones or muscles or other proteins, or it's breaking something down such as your breakfast or your lunch. It's taking those macromolecules and it's breaking it down into its monomers so that way you can use it as fuel and nutrients in your body to fuel yourself, to build yourself, and so forth. So what we have right here is we're looking at number one, we're looking at an enzyme reaction diagram. So here the enzyme is breaking something down. It's doing a hydrolysis reaction. So it's taking this, which is this substrate, and it's turning it into a final product. So this is just like what we had in the lab. So we had the full toothpick and we broke it down into like toothpick pieces, right? So this blue thing right here, this is our enzyme. Okay. And so the enzyme here looks like a Pac-Man, and the mouth of the enzyme is called the active site. That's where it's going to grab onto the substrate. So it fits perfectly, which kind of goes into number two. Some of you missed that, even though I highlighted it, but enzymes cannot fit any substrate. Big false. They're super specific. Even if you look at this substrate, it fits perfectly into this active site. Number four, where the enzyme and the substrate are combined, this is the complex. All right. So again, just being able to look at this diagram and pick out what you're looking at, what pieces are applied to these words and what it's doing. So, and make sure you look at these arrows. Some of you mixed up substrate and product because you didn't know where you were starting and finishing. Okay, then we go down to number three. This is looking at a graph of the enzyme. And so be really careful here. I said look carefully. So it said, where is it functioning at the same rate? Here's rate of reaction going up. Okay, and then here's temperature. It's actually right here at this cross section. So they're at the same level right here, the same reaction rate. Some of you put 0. I couldn't take that because I said, where are they functioning? They're not functioning there. So I took anything from 45 to 49. Again, careful reading that, that graph there. Some of you put 59 and I was like, nope. And some of you also put 50. I couldn't take 50 because if you look really closely, 50 is actually at 0. So that's where it's denatured. Number four, what's a pH where both enzymes are denatured? I took anything like 0, 4, 5, 6, 10, anywhere where it's like flatline, it's obviously not working. So all right here is the enzyme functioning. You know, denature is where it's not functioning at all. So anything like that I took. Some of you for number three put the word yes. And I was like, what does that mean? So I don't know if you just didn't read the question or you're just being kind of careless. Please, on the test, make sure you read that question carefully. Reread it if you have to. Make sure that you're sure of what it's asking. All right, same exact similar questions are going to be on the test. So you want to make sure you're really reading that carefully. Number three goes into what an enzyme does for reactions in your body. So they are biological catalysts. Number 6, which means they lower activation energy for reactions, and in turn, they speed up the reaction. Okay, what that means, activation energy is the energy that is needed to get that reaction in your body started. All right, so without the enzyme, you would need all this energy to get to the products. All right, but with an enzyme, it lowers it down, makes it easy peasy, and then boop, just that little bit of energy is needed and you can get to your products a lot faster. So this is actually represented by line 2. So again, enzymes lower that needed energy to get that reaction started, and thus they speed it up because you don't need all this energy. You only need this much to get to your products. Okay, again, similar thing will be on the test. Just make sure you can kind of read that and pick out what you're looking at. Your reactants here in this case started higher than your products, so you actually lost some energy, and most likely in the form of heat. So this is an exothermic reaction here. All right, let's scroll down to number 7. Enzymes are proteins. You are a bunch of collection of protein and some lipids, but you are protein. Your hair is protein. The structure of your body is protein, your bones, your muscles, and no surprise, enzymes are too. So enzymes are special proteins. You take amino acids, which is the monomer, string them together, you get a 3D shape of an enzyme that does a very special job in your body. All right, number 8 and number 9, you're looking at this graph right here. It is in Celsius, okay? So enzyme activity going up. Number 8 says which enzyme has the highest amount of activity at 40. So here I'm just gonna like boop up here at 40. X is higher. So X has a higher activity at 40. It does, it's above Y. So that would be X here. And then number 9, which has the largest range? Definitely Y. Y is going all the way from here all the way to here. It actually kind of denatures around probably 90 or so. But Y has a huge range compared to this range for X. So a lot bigger of a range. And so it's a little bit more versatile of an enzyme. A lot of human enzymes are very narrow ranges. We don't have too much of a tolerance outside. And like I told you guys with temperature, you know, too cold, too hot of a fever, and you're denaturing your enzymes. So, and same with our pHs. pHs are really specific, very, very narrow ranges there. So we have very sensitive enzymes compared to other organisms. All right, number 10. I'm looking for what does denaturation mean? I need to see something about structure and shape and function. Basically, they don't work anymore and their shape is lost. So instead of having this wonderful shape that could fit a substrate, sorry, I'm drawing that bad. Instead, you denature it with pH or temperature. That ruins the shape of the active site. So instead of it having this nice active site that would fit the substrate, it's kind of like this, right? And it's no longer going to fit that substrate. So it doesn't work, no work, and the active site shape is ruined. Okay? And again, how do you do that? pH and temperature. Again, why we have those negative feedback loops to regulate our temperature, making sure that if we get too hot, we sweat, right? So that way we don't get too high of a fever and denature our enzymes. Same with pH. You have buffers in your body that are going to help regulate that pH so that way you don't denature your enzymes. And we sort of talked about that with acid reflux and Tums. There's other medications that can help buffer, but you guys are young. Your buffer systems work great for the most part. So that is all we have about enzymes. And like I said, temperature, using that high heat of vaporization, that sweating to monitor our temperature so we don't get too hot and denature our enzymes. But there we go. Again, just make sure you're sort of paying attention really carefully to what the question's asking and be able to look at these graphs and diagrams and pick out what is going on and what applies. A helpful tip would be your packet has the purple agenda on the front. If you flip that to the back, there will be a list of learning targets with little check boxes. Before the test on Tuesday, spend some time today in class. Go through those learning targets and put a check or an X. It's going to help you narrow down your studying. So look back at this quick check, look at your water quick check, and go through those targets. Which questions did you miss and what does it apply to? Because how do I make these quick checks? How do I make the test? I look exactly at those learning targets and what I expected you guys to know. And that's how I make the test. So if you want to know what you're missing or what you need to study, look through that. Just do a check or an X, and that will help you narrow your focus. So be very careful, thoughtful about these questions, know what it's asking, give thoughtful answers. There should be a Wayground quiz for the unit that will be really helpful today that you'll do in class. And then you have the study guide for the Monday assignment, which you could be working on as well. I'm also going to put a grade check for the Monday assignment. So there will be two things. So that way your parents just aware at where your grade's at and the fact that you have a test on Tuesday coming up, which is very important. If you have any questions, please send me an email, very accessible via email, and I can get you ready for Tuesday if you need any help. All right, thanks, Kate.